Hey guys, what's happening? Hope everybody's doing good. Just popping on here for a quick one, hopefully. Had some stuff going on and just want to pop in there. Hey, Major. Hey, I seen you over on, I was watching Ilea over on Survivor Games. You guys done? I know you guys were live. I was actually going to try to do a love bomb over there. But I guess not. Hey, Anna, what's up? I say, okay. Guys, just a little precursor here. I'm sick. Just in case you guys hear that little bit in my voice there. Bronchitis, pneumonia, that kind of thing. Yeah, high fever. So that's why I didn't come on earlier today, because we've had stuff going on quite a bit. Hey, George, good to see you, man. I was over there watching Major. I was actually, when I went live here, I was going to love bomb over there. In other words, I was going to get everybody that was here in my live chat to go over to her live chat why she was live. Hey, Blue Dazzle, good to see you. That's what I was going to try to do, but obviously the show's over. So, and that's no big deal. We'll get her some love over there one of these days and see. If you guys don't know who Survival Game is, she does a really cool prepping game show. The Major was actually over there as a guest today, and another person, I can't remember who now, but they do. It's like a prepping trivia game. It's literally like I think she bought the game at a store somewhere or on the internet, but she pulls the cards out and she reads the people from the prepping community questions, and see how good they do at answering rather difficult prepping questions sometimes. It's really fun. It's fun to watch. You can learn from it too, so it's pretty cool. I'm gonna try, Rose. I really am. I'm sure you guys can kind of hear it. Hey, Leisure, how you doing, bud? If I ever make, we're gonna try. Yeah, I say that way too much, don't I? Try to keep this one short. I just love you guys too much, man. That's just what it is. Sorry, guys. I don't mean to cough. I'm trying not to. But anyway, okay. We're gonna keep this one short. Leisure, man. I really hope you're feeling better, Leisure. All right. So we're gonna go ahead and get into it. And also, guys, at the end of this one, I'll go more into this, but we are doing a call-in show now over on the Lifeboat, and we've had 2 shows under our belt now, and it's really, it's grabbing some, momentum there. It's changing the dynamic a little bit, and it's good. We're able to communicate like that, and if anybody wants to call in for questions and stuff like that, they can, even if they disagree. So anyway, guys, we've had a radiation storm. We don't get too many of these. We've had them before, and I've reported on them before. But as we go further and further into the sun cycle towards solar maximum, you're going to see the chance of these things start going rising and rising and rising. And I know that I haven't shown very many of them, and there's a reason for that. It's because we haven't had a whole lot of them. And they are different. They're different than what you would typically think. The timing of them's even different. All right. And so let me explain. But first off, guys, we've had the M-class flares has been crazy. All right. 1, 2, and these are substantial ones. And I'll go into more detail here in a second. But M-class flare, M-class flare, M flare. There's another M flare, another M flare, and we just had another one. So within the past 2 or 3 days, we've had 6 to 7, even possibly 8 M-class flares. Now, if I'd have said that to you guys last year, you guys' chin probably would have hit the ground. And this is what I want people to understand, that this is it's a normal thing, a normal thing to get this active. Sorry, guys. But it's, there has been a lot of consecutive rare things happening also. Okay, that's what's piquing my interest right now, just so you guys understand that. And just to give you, well, let me go into this first. I'm going to show you what I'm talking about, the radiation storm. It's right here. Okay, we're looking at protons. Is how they typically will gauge these. You got an S1, S2. Again, same kind of thing. As things get more intense, the level of the storm level will rise, right? And I know we haven't talked a whole lot about radiation storms, so what I'm going to do is I'm going to bring this one to you here real quick and show you what we can expect to see during each level of storm when we're talking about radiation storm. And anybody can go to this right here. Just go over to NOAA. It's down at the bottom. It's in the links and stuff down there at NOAA Space Weather Prediction Center. And you'll run into this, right? So if you hit solar radiation storm, and this is what it's going to give you what you can expect for each level of storm. Just like with the geomagnetic storms and flares, right? Radio blackouts. So what can we expect in S1 storm? Biological. What they're talking about biologically there is your body or any biological thing affecting it. None. Won't affect anything. Okay? So it's not going to affect your body, at least according to what is to be known. All right? Satellite operations. This does not affect satellites at an S1 level. Okay? Other systems. Minor impacts. This is where you start to see a little bit of something. Right? Minor impacts on high frequency radio in the polar regions. Why the polar regions? You're probably asking yourself. We'll talk about that in a second. But small effects on, if you go up to the second level, which is be a moderate, passengers and crew in high flying aircraft at high latitudes may be exposed to elevated radiation risk. Okay, what they're talking about there is sometimes with a very, very strong, not a very strong, but with the stronger radiation storm, the closer you are to the poles and the higher altitude that you're flying, it's going to affect that a lot. Okay, and what I mean by that is these radiation storms can give you enough radiation. It would be like you going to get an X-ray or even a CAT scan. Wrap your brain around that for a second. Okay, it's known that they didn't do this until a few years back, but we no longer even try to allow our kids to get X-rays when they're young, unless it's just absolutely necessary. Why is that? Well, the reason why that through the study and through time, they figured out that it can affect their reproductive organs. It can affect them in very, very negative ways. So they won't do X-rays on kids unless they need to, right? It used to, hey, he might have a hairline fracture. Let's go X-raying, that kind of, or her. Well, guess what? They don't do that anymore. Go to the emergency room. They're going to tell you, no, we don't want to do an X-ray unless it's absolutely necessary. So I bring that up for this reason, because when you're doing that, and you're getting these radiation storms, depending on what level they are, it is like getting an X-ray. So, just saying. I think that helps people understand what's going on. Yeah, exactly, Angel. Never scared, no fear, love and light. Exactly. Exactly, no fear. Hey, Deepquake, what's going on, bud? Okay, so as we move back to this, guys, the M flares is what cause the radiation storms. Okay. And I oftentimes show you guys this X-ray chart here, and it's just a spike straight up and straight down, right? Well, you see what's happened here? It happens and you got a slow taper off. That's a long duration flare. That's what that's showing you. You get the big initial, blast from X-ray, and then it continues to produce X-ray for hours. Like, extended amounts here, guys. We're not talking about just like normal stuff. We're talking about a big blast of X-ray, and it stays at a higher level for, hours on end here. If you look at the time frame here, these bars down here, these are 3-hour data points. So if you kind of relate that to that, that's a 6-hour solar flare. Hey Tommy, what's up? Hey Wolfie. So yeah, and yeah, it's not a good thing to be high altitudes or in a plane during these kinds of events. You really shouldn't, especially pregnant women. pregnant women and people that fly all the time, you really have to pay attention to this. Now, the same thing that with solar radiation storms, the same thing applies to when and this is why I report on cosmic rays. Okay? Cosmic rays are, yeah, we have to pay attention to those because it's the same thing. It's radiation. It's the exact same thing what I'm talking about here. So the same warnings that apply to radiation storms, it applies to cosmic rays also. Yeah, or pregnant men. Yeah. You guys remember that movie? Oh, I shouldn't squirrel off here. You remember that movie, what was it called? I forget, but Arnold Schwarzenegger, he was pregnant, right? They implanted a baby in him or something. Kind of crazy. I remember that. Anyway. So, long duration solar flares do have a much greater chance of sending a radiation storm our way. So what's the difference? Yeah, exactly, man. you got the difference is the flare is X-ray, moves at the speed of light. Radiation storm is highly excited, energized protons. Okay, and that takes some time to get here. Typically, it's here within. It just depends on what's going on. We can have it here in 20, 30 minutes. These move at different speeds, similar to like CMEs. It just depends on how fast they're moving. I meant to say, it depends on how strong the eruption was. Okay? What about the plasma? Yeah, the plasma is what you look at with the geomagnetic activity. Okay? That right there is, that's when we're talking about geomagnetic storms, and we're actually forecasted to be in a G1 here anytime. So, and we'll get into that too. But all three of these, we don't oftentimes sit here and talk about all three of these things being in storm level, and we're getting ready to. I can tell you that. But as you see this radiation storm kind of slow down and kind of start tapering off, look what happened. We had another flare. And anytime you see this yellow, that's just showing you it's longer duration, that kind of thing right there. Notice that it's a fairly long duration storm itself. It's not just a spike and right back down. So I look for this thing to start creeping back up. Well, it actually kind of is already. See that? So we may end up in storm level again. What does that mean for most of us on this planet? Nothing. Okay? It really doesn't. I just showed you guys, and that's why I wanted to show you guys this so people don't freak out. You know, S1 storms, unless you're flying like high altitude towards the poles, you're not even going to know anything's going on, right? I mean, they're not even going to worry about it. So what I'm saying is that when we talk about an S2 and S3, we don't want to come on here and start crying wolf. Though, you know, no offense there, Wolfie. I see you in here. Anyway, you don't want to come out here and just start blowing an S1 radiation storm way out of the water, right? And then when we come on here and we say, hey, there's another radiation storm, and it ends up being an S3 or an S4, then nobody listens to you. You know what I mean? I'm not going to come out here and just start blasting, oh, an S1, S1, S1. You know? Yeah, Tommy. I'm not going to do that, right? It's newsworthy. That's why I'm talking about it. Right? And we need to know when these things happen because it helps us understand what's actually going on. It doesn't necessarily mean that we even need to take any kind of action or anything like that. We need to be aware of this because if we're at an S1, just like when our X-rays up here, if our baseline is way down here, you see the protons? If this baseline had been up here when we caught these other flares, we're looking at an S2 or an S3. See what I'm saying? So we really need to, yeah. Let's see here. What you got there? Rose color? I'm ready for the, yeah. A lot of us are ready for that. That's for sure, you know. Get a little bit of rest, you know what I mean? Anyway, so, yeah. Flare, you know. And then, again, radiation storm. And now we're probably looking at some geomagnetic storming here in just very, very shortly. You know, and I'm really hesitant to say it's going to be almost a definite. The last 2 times that I've said, hey, we really need to pay attention to this, and we did, right? And we did get into storm level, but they ended up not being as a direct hit as it typically is. Not typically, but as we thought they were going to be. And we just didn't get into the storm levels that they thought we were going to. And that was contrary to what all the models were saying, right? And that's what we have to go off of. We have nothing else to go off of, guys. But as you can see here, NOAA's forecasting G1 storming, here. Well, what time is it? Let's see here. Yeah. So it would be here, right? Yeah. So here in the next 12 hours or so, they're talking about us being in the storm level. And then we'll be, getting into the 29th. And as we get into the 29th, that's going to be like that. But we've also had, guys, let's see, what did you say there? Solar flare they hit down on the right. Oh, yeah. Looks like an X flare. Yeah, and I have not explained that in a while. So you know what? Let's just, as you talk about that, we'll go there in just a second. But I want to show you guys what this looks like right now. Okay, I've shown you guys this a lot, and usually when I show it to you, you're just seeing this blast of a solar flare, right? Look what's going on around our poles. This is the radiation storm, guys. This is an absorption model. D-region absorption model. So, hey, what's up, Jackson? So, look at this. Okay, so now we have a lot of radiation just hanging around our poles. That's why they tell you, closer to the poles, more issues, right? So you can see as we get more flares, how these things start to rise again. And it's just kind of, if this stuff continues, this is going to keep dumping this and this and this all over us, right? Now, I don't like to come out here and say anything bad and stuff, but what we talk about is, if we ever look at this graph and you start seeing these colors, like at the equator, that's a big radiation storm. You can see how close it gets to Australia. It's already, and up here, guys, you can see it's in Canada, obviously. I mean, parts of it. Alaska, most definitely. So if I grab this, and I bring this up because Australia doesn't typically, most people don't equate Australia with having these kinds of issues that often. Well, they actually do. So that's why I'm bringing them up. I know I got a lot of brothers from down under, a lot of sisters too. So, but as I move this, just watch how this kind of creeps up. See that? See it reach up? So, I mean, it's, in the southern parts, of Australia, New Zealand's out here too. All those kinds of things, right? So we're looking at that, and that's what we're seeing as far as radiation storm. So if you come over here to the de-absorption model, and you see this stuff hanging around the poles, that's what that is. Yeah, Vegemite, kangaroos, and fly. Yep. That's awesome, dude. Anyway, sorry, man. Man, I already told you, don't make me laugh. See? I made myself laugh. Daggone it. Anyway, this is NOAA's model, right? So I'm going to show you the Cannibal CME. Now, I put a question mark by that, right? Why did I do that? Well, because that is really not a good name for what I'm getting ready to show you. Because it's not one CME eating another CME. It's a CME catching up to one in the front, and they don't combine into one, guys. We're talking about magnetics here, right? And so when you get positive and positive next to each other, what happens? They push away from each other. So just like in an interplanetary magnetic shock wave, and I've talked about that before too, it's very similar to what we're talking about here. These particles, they don't actually smash into each other. It's not like, CERN. I'm not going to say that word because Yeah, if you ever say that word here on YouTube, I promise you your video will get like 2 views. Anyway, um, so when these particles, when they catch up to one another, they're pushing against each other, guys. They're not trying to come together, right? So what I'm saying is, instead of like colliding, they don't. And that's what the particle colliders are for here on the planet. That's why it's so hard for them to be able to do that, because it takes a lot to do that, right? Because their natural reaction is to push against. So they got to get things moving in a very high speed. So when they do collide, that's a massive amount of energy, right? So, and don't make no mistake, sometimes the particles do collide in space, right? But for the most part, what we see is basically what I just said. You get kind of like a snowplow effect, and all those particles build up in between those two CMEs that are now really, really close together. So then it really just, it'll bam. I mean, it really does. When it hits, it's pretty intense. It's some intense stuff, guys. All right. So let me show you what I'm talking about. I'm showing you Noah's model because it shows it better. Okay. Now, first thing I'm going to say, you see a CME blowing off right here. Now let me, I'm just going to zoom in a little bit here, and we'll just do it this way. Hopefully you guys can see better that way. So you can see a CME just, coming off. Now look what happened. See that? Bam, and then bam. I mean, like right behind it. I mean, it wasn't, it was just like, I think it was like a couple hours behind it. So as we keep moving forward, look how fast it catches up. If you didn't know what you were looking at on these models, you would probably not even see that. Especially if you were looking down here at the velocity. So what happens is it catches up right there, and look what's happening. Do you see the density just like building up right there? That black, look at the black over here. On the how dense they are. Yeah, you know what I'm saying. On how intense the density, or how much the density is. You see the black? That's as high as you can get on this model. So yeah, you can see what's happening there. Now it's a top-down view here. Now this is the side cut, and this will let us know if it's going north or south of us on the side cut. So as we move forward here, it catches up right there, and then you see what it does there? I find it interesting that this happened. Let me back it up. Okay, they're not they're not one right there. You know what? I'm gonna try to blow this up a little bit more, see if it helps. It may or may not, guys. I don't know. Doesn't look like it. Sometimes when you bring these, when you like try to enlarge by increasing the zoom on your computer, it will not move anything because the way the website is. Anyway, watch what happens. It catches up, right? And then it almost looks like it splits in two. It doesn't split in two. It's just pushing. And then right here, all the density looks like it got pushed off to this direction. What direction is that? Well, this is Earth. Okay? So, if you look here, this model is showing you exactly what I'm talking about. Up here, the green line is conditions at Earth. Red line's conditions at stereo A, which is this red ball. The blue line is conditions at stereo B, and I'm not going to get into that satellite itself. We don't get to see information from that. I'm not sure if they get good technical information from that anymore. We lost contact with it, and then we regained contact with it, and there's a big story around it, right? But you can see how all the density got pushed this direction. So even if we do catch, and look what happens here on stereo B. They take it right on the face, according to this model. All right. Again, remember, this is just a model. This isn't like 100% fact. This is a forecasting model. Just like your weatherman, it's going to change. I promise you that. But as of right now, that's what they're saying. So you can see that the density is 50. That's high. I mean, that's really, really high. It doesn't get, they only show you up to 60. So that should tell you. Now notice up here, we're, at Earth, this model's forecasting probably like, I don't know, a little over 10, 15, something like that. But look at the velocity. Okay, this is the speed. And I'll back it up so we can see the whole event here too. See it catch up right there. And we move forward and see how things kind of got pushed off down towards us. That's very, very typical. Okay, when things fire off in this direction, because of the end little spiral and because of the spiral motion, everything's moving. You'll get kind of like this backward effect, and it actually will kind of wrap around, I guess, without trying to go into more detail. Hey, thank you, Miss Honeybee. Appreciate you too. I really do. But you can definitely see how north-south this isn't. That looks like we're going to take at least a sideways hit from this. That's what this model's showing. So we'll have to see if that all, equates out. Now it's right on the 29th, right? So that's why you're seeing this. That's why they're forecasting this, right? So what that means is, if that model is off a little bit, like the direction of it, if the direction actually has it going a little bit more to our east or west or whichever direction you're talking about, when you're looking at the sun, guys, things are backwards. They say east when you're looking at the sun, and for me and you, if we were looking at a map, it would actually be west. So things are kind of reversed with east-west. But with that being said, if the direction is just a little off on this model, we may not see nothing. But also, if the direction's a little off the other direction, we can see more. So that's why these things are hard to forecast, right? So that I think what they do over here at NOAA is they just kind of try to find the middle of it, and that's what they forecast. So that's probably why you're seeing this, because on the low end we might not see a whole lot of anything. On the high end, if we were to see this like come more our way when we got all that density and stuff, that's a decent possibility. We're looking at at least a G2, maybe even a G3 if the direction was off that much. Now we're only one day out now, right? So we're closer to the actual thing getting ready to hit. So their forecasting gets a lot more accurate at that time. Now, if we were looking at this and this was 5 days out, I wouldn't even be like talking like this, right? I do think that they're probably pretty accurate on this one. And again, though, just a little bit of a movement to one direction or the other, it's going to make a big difference on the conditions we end up experiencing. Okay. But anyway, there's that radiation storm. So let me show you. Here's your solar wind and your BZ and stuff. I'm not going to waste time on this one right now because nothing's going on at this second. Here's our density, though. I will show you this. We were up in the 20s here. And our BZ, we actually dipped down here to -6 or bigger. This actually got down to -10. That means we're in a negative orientation. Our magnetic field is basically pointing in a negative direction, which allows stuff to come in easier. Hey, JJ. Hey, Verte. What's up? Hey, Dieter. All right. So when that gets tilted like that, stuff comes in easier. That's all I'm saying. So let's take a look at these flares. And so I'm going to pause that right there. Grab it. See what we got. Okay, see this is something else that I haven't mentioned yet. We had a filament release also. Okay, that's a CME, but it's from a filament. It wasn't from a flare. So let's I'll let you guys take a look at that real quick. It happens right here. I go too far. Yeah, I'm gonna maybe back it up a little bit. Okay. Now, again, It's right here. It's not going to be hard to see, but it's not going to look as intense as it actually was, though. And why I say that is the sun's the actual background, not the darkness of space. You see how this is, you can see this really well? The reason why you can see that really well is because the contrast between the black image and the red. That's why you can see it. Back, if anything happens like right on the face of the sun, it's kind of hard to see sometimes. So watch right here, and you'll definitely be able to see this. But anyway, see that? Okay. Now that happened outside of a sunspot. There was no sunspot there that I could see. I guess I could check that here in a second too, but I'm pretty sure it was just a filament release. Okay. And those filament releases, that's plasma. Okay. That is a CME. That's what that is. So just so you know. But again, with that happening right there, it did look like it was kind of going this direction, but it's still right there in front of us. Right? So, yeah. Now, this down here, that's pretty active area down here. That thing has been hanging on here, and it's behind the limb, which means it's, kind of almost on the backside of the sun. But it will rotate in. It looks like it might be ready to start rotating in now. It is. So, yeah. But you can see how that never even doesn't move a whole lot. Just kind of hangs out there. Those are magnetic connection lines, and that's plasma traveling on those connection lines. Okay, so here's that other flare. This is why I wanted to show you the what somebody said that looked like an X flare. Well, it's not an X flare. The camera just interprets it as taking on the shape of an X. Okay, that's just the way the imaging works. So if you look at it, see how you got kind of like an X pattern? And that, I used to actually think that way also. I used to think that made it an X flare. That's not what makes them X flares. What makes them X flares is actually how much X-ray is pushed out. Okay? So that's what we're talking about when we're talking about the, levels of flaring. But no, we're not worried about no EMP effects right now, Dieter. Yeah, there's nothing going on with that yet. And again, guys, if I ever think that is the case, I'm going to come tell you right away. I'm not going to be showing you anything else. But this is probably the one they were talking about. See that? See how it takes on the X pattern? Right? Now that eruption was up here, as far as that filament release I showed you guys. So, let me just grab that, and we'll just do this. Okay? Notice what you see in here. I find it really interesting that both of these are like really, really active. And they're basically on the same latitude line on the sun. Look at that. I mean, it just, yeah. Multiple flares from multiple different sunspots. And you can definitely see the long duration on this one. So let me back it up and I'll show you. Watch when it gets real bright. That's when it first starts flaring. And look how long it just stays that bright. And then it continues to go. That right there is why we had a radiation storm. Okay? It's the duration of it. It just allowed more stuff to fly off. Yeah, you're right. It was a bright one. 100. Now you can actually see this other eruption here I showed you guys too on the green one. You don't always see it on this imaging, but this time it showed up. So let me show you. See that? Watch you get disturbed right there. There was no sunspot there. Okay? So, anyway. So, those are the flares. Now, let me show you guys the eruption as far as, well, I tell you what. Let's look at the 211. Because this does show you the atmosphere of the sun better, the corona. And we're able to see, like, directional purposes and how much it's actually disturbing the sun's atmosphere, and that could give us a good idea of how much plasma actually left the sun. So if we just watch this for a second, we'll get a good idea here. Actually, let's just grab this and okay, so watch the atmosphere over here. Just like, see that? See how it disturbed it even all the way up through here? That's telling you that that was, yeah, a decent sized one. Yeah. So, and why this one's more is going to become more and more important is because it's rotating to be right in front of us. Hey, Whitetail. So, yeah. And also, guys, we connected to this coronal hole too. So we're going to be getting increased solar wind from that anyway. So, just saying. All right, let's go over to seeds, and I'm going to show you some of these eruptions. I mean, some of these were pretty impressive, actually. I'm just going to go down here and hit these. Let's check this out. Okay. Actually, that's not really showing us much. Now, I know that looks all kinds of crazy, guys. It's not. Okay, just let me explain. Okay, when you come over here and you see this imaging like this, the tool the tool actually thinks it's seeing like a CME. That's not a CME. The camera got flooded with light, right? And it didn't know what to do. Basically, it couldn't react fast enough. So this is what it did. That's all that is. And when you see the blue and the red hash marks here, they're trying to outline how big it is and how how wide it is, right? That's what those lines are for. So when this tool sees those lines, it thinks there's a CME. So that's what it is. Okay. So when you see these kinds of anomalies and stuff on the camera, this is nothing. It really isn't. Okay. It just means that there was an anomaly, which would be most likely a lot of times it's just a big flash of light, and the camera can't handle it and it don't know what to do. So it starts taking pictures and thinks there's a CME, and you can definitely see that, if for this reason right here, check this out. If there was actually a CME, you guys know where the red and blue lines would be? It would be at the edge. Okay? That's what this thing does. And I can show you that here in about 2 seconds. I'm going to. Let's just go back up here and oh, wrong day. Okay, so I'm gonna back it up. Okay, here's one of the eruptions. Where are these red and blue lines? At the edge. So that should tell you that that's just nothing more than a camera anomaly from the one I showed you guys earlier. Okay? It's really that simple. Hate to break it down simplistic like, but that's what it is. And notice how it keeps following the edge of it out. That's what this thing is designed to do. But anyway, this is one of those, this is that double eruption I was telling you about. Okay? First eruption. They happen so close together, it's hard to tell. So let me go back to 26. I think, yeah, there it was. I thought it was on the 26. I was wondering why it wasn't showing up. Okay, so what I'm going to do is I'm going to back this up. And then you get to see the first one right there. There's the second one. See that? See how close out that came? And it went right into the next day. So just so you kind of understand that, I guess. All right. So that was the Cannibal CME. And I'm calling it a Cannibal CME because that's just the term that's being used. Again, I've already explained that. But I don't want anybody to get confused on that. So, it's the wrong button. Wrong button, Mark. Wrong button. Okay, so let me take you back to seeds again. I didn't mean to hit that. So, yeah, guys. I mean, that is definitely that is the Cannibal CME. Okay. It caught up to this first one. Back it up here. You know what? I'm gonna do something here real quick. Watch this. Hey, we're going backwards. Sometimes when I'm trying to find something, I'll actually do this, and you'll see different features when you run it in reverse like this. It's amazing how much more you can see by running them in both directions. That's just something I had to learn on my own. But it's actually beneficial to be able to put it in reverse like that. But So there you go with that. Now let's go look at the side view, or partial side view, I'm gonna say, and see what we see. Yeah, see, this is exactly, yeah, I looked at this earlier. I thought maybe there would be another one, but yeah. So what we're looking at here, guys, again, Earth is over here, but what I'm gonna do, let's just let's go back here. Earth is here. The satellite I'm showing you is right here. Okay, so that our view, when you're looking at this, the position that this satellite is in is here. So we're not 90 degrees anymore. This thing used to be out here. Okay, now it's here. So it changes its perspective. And why is that important? Well, when you change your perspective, especially that drastically, it will change what we actually see, what direction it's actually moving. You know, if this thing was here, if the satellite was here and we've seen this would most likely be almost like a direct hit, because Earth would be right here, right? But because we know that the satellite's moved, now we're changing our perspective. And when we see things like this, that looks like it's going to our right or coming right at us, it could actually be missing us to our left. If that makes any sense at all. And anyway, it changes the perspective. So this used to be a really good way to kind of see what directions the CMEs were moving when the satellite was way out there. But now we don't get those kinds of, yeah, you know. We don't have the benefit of that now. It's closer to us. So anyway, there's that one. And then let's go to the next day. Okay, and then here, that is the second one. Okay, so they're both here. They're both showing up. That's right. That's right, Tommy. Always change your perspective, right? We talk about that on our other addiction recovery channel called The Lifeboat. Excuse me. Sorry, guys. Sorry about that, guys. I had to move my mic away for a minute. I didn't want to blast your guys' ears with a cough. Okay, so let's just let's go here. Spaceweather.com. I show you guys this channel about every time. It is Dr. Phillips. He does an awesome job over here. If you guys want a really quick reference of what's going on at any given time, go over here. His page here is most definitely, it's in my description. Okay, so there it is, right there. Thanks, man. I appreciate you, Tommy. I'll take all the prayers and good thoughts and love I can get right now, guys. I promise you. Hey, Nita. But there's the link to that. If you guys want to come over here and check out spaceweather.com, please do. Go give them some love. I'm not going to read their article to you like a lot of people would. I won't do that. And it's okay to do that, right? If you're reporting on a story, you're reporting on the article, it seriously is okay to do that. You know, it's fair use. If you're just commentating, reacting, those kinds of things, it's very much fair use. But I just choose to not do this because, you know, I talk about this subject a lot, and these guys are doing a lot of hard work over here. So go give them some traffic, reward them for the work that they're doing. What's he talking about? Oh, okay. He's talking about the Cannibal CME here also. Okay. So I'm not sure if he agreed with what I was saying or not. I'd have to go read it, but I haven't had a chance to take a look at it yet. But please go give him some love. I did see this part earlier. That is that eruption I was telling you about, guys. So, but if you want a quick reference of how many sunspots we got, come over here. They're right here. And it'll give you a 24-hour max as far as the biggest flare we've seen, and a 6-hour max. M1 for both right now. It was an M7, believe it or not. Hey, Ashley, what's going on? Also, guys, you guys come over here, you get to see near-Earth objects. This is measured in lunar distance, the distance between us and the moon. So if there's an asteroid or a meteor flying by, if they sometimes, guess what, guys? I know some people have never seen this particular chart, but every once in a while you'll get on here. It's more than actually than every once in a while. It happens quite often. You'll see one pop on here that wasn't there, and it will be for a date that had already passed. You know what that means? That means they didn't see it until it already passed us. So that's, yeah. And just to steal a line from the movie Armageddon, what did that guy say? Rockdown said, what was it? Begging your pardon, it's a big ass sky, something like that. Sorry about the cuss word there, but it really does apply here, guys. And the reason I say that is space is huge. So when we're talking about these distances, lunar distance, yeah. So even like a 0.5, which I showed you guys that a couple days ago, it's halfway the distance between us and the moon. Halfway to the moon, that's the distance. That is still over 100,000 miles. Right? So to us on the planet, we would be on Earth here, we wouldn't even be sweating that, right? I mean, but when we're talking about space, you better be paying attention. So, all right. Also, you guys get to see noctilucent clouds, and they're starting to wane out now, okay? Because we're coming into fall. As we move towards fall, these are going to go away. They only happen in summertime. Summertime in the northern hemisphere, and then summertime in the southern hemisphere. So as we're going towards fall, these do start to fade away, all right? And spring, same way, okay? But these are just, it's just water vapor that freezes around meteor dust that's been hanging out around our poles. So when we start seeing these blue metallic noctilucent clouds, they start creeping up towards the equator, we start paying attention because something's different. You would think it would take, colder weather to make more. No, it's not true. It's actually the reverse. It takes hotter weather because what happens is it's glacier melt and just whatever ice or whatever's on the ground on the poles during the summertime, they start to melt a little bit more, so it adds water vapor. And when that vapor gets up to the highest parts of our atmosphere, the ionosphere, it freezes around this meteor dust. And that's what causes these clouds. So when we start seeing these blue metallic clouds, closer to the equator, we kind of perk up and pay attention because that means something's changing. So, just saying. Hopefully I explained that well enough. That's not a easy thing to explain to people. Yeah. Okay. So, all right. What's next here? Let's shoot. Let's go here. Guys, I did want to mention, like I said before, I'm gonna back that off a little bit more. What the heck am I doing here? All right, there it is. We started a call-in show over here on the Lifeboat, guys, and we've had a really couple good shows. We had Jonathan called in today, and then we had guys. Listen, you guys know who Jeff P is, right? Anybody that's on my channel, you guys know who Jeff P. He's a legend in our freaking community, right? Am I correct? Right? Come on, guys. Give me a 1 in the chat if you all know who Jeff P is. Well, guess what? Jeff P called in over here. So, what I'm going to do is I want to share this to you guys. What the heck? Man, this thing is... I'll tell you what, when YouTube does... what the heck? I'm going to close that. Yeah, close that, stooge. When YouTube does updates and stuff, I hate it because everything changes on it. It's stupid. Anyway, so I'm going to share this to you guys. I'm going to put this link in the chat. Jeff P called in over here, and he was our first caller ever. It's the first time we took calls, and he had some stuff going on in his life with some tenants and stuff, and how he's a landlord and stuff. So come check this out. Come check out this call. All right. There's the link to that particular video. please give us a subscription when you come over here, and then come back tomorrow and call in yourself if you want to. You know, we typically talk about addiction recovery and alcoholism, and any questions you have. There's nothing off the table. You know, if you don't agree with what we're saying, please call in. Come over there, call in, or come over and just check us out. That's all you gotta do. I mean, that's all I'm asking. But if you guys want to hear Jeff's call, it's on this video. And you know, he stayed on the line with us for about 20 minutes. So I mean, and he had some really good insight, some really good advice, and just a lot of good conversation. So if you guys want to hear Jeff, I know he hasn't been posting a whole lot, but y'all know, you know what I mean? Oh. But anyway, guys, so that's you know, this is I call it my second channel. Me and Tommy, we run this channel together. He started it. I kind of got brought on, and we've just been running it together for over a year now. And I know I've talked about this channel a lot here. It's because I hold it really dear to my heart. I really do. And everybody there, I really do. I got real love for people over there. And here too. I'm not saying that. But I'm just saying we're able to become a really close-knit family. And as soon as you walk in the door over there, you're going to get hit with a lot of love. First thing they're going to say to you, hey, welcome, what's going on, how you doing? You're not going to pop in the chat and say hi and then not get a response. That happens on a lot of other channels. You will not get that there. I promise you. So, nah, man. We are the Lifeboat, brother. We are. So, but yeah. So come check us out over here, guys. I'll drop the link one more time. Again, Jeff P. Did call in over here. So I know you guys know Jeff. That's why I'm bringing it up. So if you guys could just go over and check out his call and, you know, give us a subscription. Come back and check out our call-in show tomorrow at 8 o'clock Eastern. We do that every week. So every day except for Wednesdays and Thursdays. Those are the only 2 days that we're not on. So, but to give you guys a little bit of a recap here, I'm going to just tell you what we got coming. We've got a solar radiation storm underway right now. Well, nope, it's kind of peaked out. It's leveled out, kind of below storm level now, but we still have some radiation hanging around. We're expecting more flares, and we are expecting geomagnetic storm levels here in just a few. And thank you, George, for doing that. I'm glad you were able to catch a live, George. I really am. I appreciate you, man. 100%. Mods, I love all you guys. You guys, man, I tell you, you guys are just awesome. You guys got the hardest and thankless job in the world. Believe me, I'm a moderator on quite a few channels, and I'm telling you right now, it's hard sometimes. Oh wow, you guys, I forgot to mention this. Check this out. It ain't oftentimes you see a 55% chance of a R1 to R2 radio blackout. That's a high percentage, guys. Wow, I didn't even see that till just now. Look at R3. You know what R3 means? That is an X-class flare. R3 is an X-class flare. Hey John, what's up? Oh, and something else, guys. Go check out Matthew Shipley's channel. Every time I see John, I always think of Matthew, because that's how I found Matthew. Back at you, Nita. Back at you. But he does, you know, he's been putting in fiber optics so he can get 4K blasted out to you guys, and it's awesome over there. So, all right, guys. So I'll just kind of keep you guys up to date if I can, you know. And I am, again, guys. You can hear it in my voice and everything. I've been sleeping a lot, trying to just get, you know, just kind of get back to myself. I've had a lot of stuff going on in my life anyway, and then to get sick like this, it's hit me pretty bad. So if I don't get back on here very, you know, quick like or anything like that, I do apologize. Hey, Trinity, what's up? Hey, it's an honor to have you. I promise you, girl. Guys, go check out her channel too. She does some really cool stuff over there. And again, guys, I showed you my subscription list, and you guys know if I was to shout out all 100 of my subscriptions, that's all I'd ever do. I already take enough flack. Thanks, Trinity. I appreciate you. I already take enough flack for doing the shout outs I do. because it does cause me to squirrel, but that's okay. You know, what I'm going to do, this is something I tried to do before and I just never followed through with it. I'm going to set up a transition sequence, basically, is what it is. And I'm going to break it down into sections. So it'll help me stay on track during the video, during the live stream. And so, like, if I'm talking about this, like X-rays, I can push a button and we'll transition. We'll talk about the CME, or we'll click over and we'll talk about earthquakes, that kind of thing. It'll help keep me focused. And I know that I squirrel a lot, guys, and I apologize. It's not intentional. I just feel like I need to give attention to where the attention's at. People that have questions or what have you. And, you know, I think it helps build a good relationship between me and everybody else here. I've gotten to know a lot of you guys, you know, on a very personal level. And you know, that's one of the most proud things I have about my channel. And again, I mentioned this yesterday. My demographics, believe it or not, it's about 50-50 women to men, but it's actually a little heavy on the women side. I got, according to my demographics, I got just a slight more women viewers than I do men. You're not going to find that anywhere else. It blew my mind when I seen that, by the way. But you know, I'm honored. I really am. And the reason why I'm honored for that is because it tells me that I'm able to talk to people that not necessarily would have been comfortable talking on another channel. And, you know, I'm not trying to stereotype or anything here, but, you know, I don't judge, right? And I try to be as sensitive as I can as a person. And I do think that kind of lends itself to a more feminine mind think like that. So, and I think, because I tried to figure out, why do I got a lot of women? Well, you know what, guys? There's a lot of women in this world to get talked down to. And I don't do that. I will never do that. Because it's just not the case. Some of the smartest women in this world, some of the smartest people in this world are women, and one of them is my wife. So, I'm telling you, men, if you're listening to me, take care of your women, would you? Just be respectful. All right? All right, guys. What you got there? What did you say there? What'd you say there? Trinity, South Toronto. Oh, wow. That's a bit. I'd have to, like, think about that for a minute, Trinity. That's a big question. It's an interesting question. For sure. Yeah, the Toronto wormhole stuff. I've looked into that a little bit. I'm not really that educated on that one though. I will look into it though. I'll give you my thoughts on it. All right, guys. I am going to pop off. Oh, thanks. Yeah. I know. I hear you, Tommy. She's a trooper, man. Telling you. All right, guys. I am going to pop off. So, God bless. Yahusha saves. And, yeah, I hope you can still drink this Kool-Aid. Oh, yeah, by the way, guys, please go check out Marfugal. Sorry, I should have shouted them out earlier. Yeah, daggone it. I hate when I do that, guys. Man. Adam and Dex are like really good friends of mine, and I tell you, I don't forget. I just assume people are already watching, so I don't really mention it like I should. I've been trying to do that. So anyway, go check out Marfugal, guys. God bless, guys.